Okay, as we've already mentioned, catalysts are substances that speed up a chemical reaction, or they increase the rate of a chemical reaction, but they're not used up themselves. So they're usually solids, often involving transition metals, sometimes in solution or gaseous, but often they're some kind of compound of a transition element. Now, we know of catalysts in biological processes. They've got special names. What are catalysts called in biological processes? Begins with an E. Yes, they're called enzymes. Now, the way a catalyst works is it lowers the activation energy of a particular reaction. So if we remember the graph we've seen before, this reaction profile, then if you've got just the reaction without the catalyst, you've got quite a big activation energy represented by this blue double-headed arrow. So there's a big activation energy. But if I had a catalyst, what I do is I lower the activation energy, and what that does is it means that it makes it much more likely that particles, when they collide, that they react, because many more particles have got enough energy to get over that hump. They've got much more energy than the activation energy. So if you've got more particles with enough energy to overcome the activation energy, then you get more successful collisions. Let's look at an example. This is hydrogen peroxide decomposing in the presence of the catalyst manganese dioxide. So what we do is we add the manganese dioxide and we produce oxygen gas, and then we measure the oxygen gas in the gas syringe. You get graphs that look something like this. Now, if you don't use a catalyst, then over time, very little oxygen is produced. But if you use one spatula of the catalyst, the manganese 4 oxide, then the graph obtained has got that kind of shape. If you use 2 spatulas, then the reaction rates increased even more, and the graph has got that shape. Notice that they both end at the same place. Why? Because you've used the same amount of hydrogen peroxide, so you get the same amount of oxygen gas produced in the end. But in the case of 2 spatulas of the catalyst, they are produced faster. How could we show that the catalyst wasn't used up? Well, you could measure the mass of catalyst used, then you could, at the end of the process, filter the mixture, and then dry the catalyst, and then remass the catalyst. What would be the equation for this reaction? Well, I'll let you write this, but hydrogen peroxide has got the formula H2O2. And H2O2 decomposes to give H2O, water, and oxygen gas. You try the equation. Like I said, if you wanted to show that the catalyst wasn't used up, you filter the mixture after the experiment, dry the catalyst, and then you weigh it to check the mass. Okay, have a go at the questions on page 107. Read pages 106 and 107 and answer the questions in your exercise books.